So the next topic on our agenda is square roots. The key term is if a squared is equal to b, then a is the square root of b. Remember we talked about as we move forward this idea of a principal root. That 4 squared gives me 16 and negative 4 squared gives me 16. So there's a 4 and negative 4. We're going to use this with solving, which will be tomorrow's lesson. So everything today, don't worry about plus or minus. It's going to come into play when we're solving tomorrow. Key features to that we need are perfect squares. Remember we talked about that knowing these values are really going to help when we move to like prime factorizing. So pay attention to that because things like square root of 81, is going to just be, a whole number 9. And square root of 49 is just going to be a whole number 7. No root, just the number itself. So that kind of lended ourselves, and we're going to focus mostly on this property here and not this one. It just alludes to that if I have a square root of 5 times the square root of 5, that gives me the square root of 25. And this idea that the square root of 25 gives me a whole number 5, a normal 5, that a pair of square roots of 5s will give me a normal 5, meaning pairings are going to give me whole numbers. So pay attention as we move forward, something like square root of 17 times square root of 17. Of course, feel free to multiply those out, but just know that's just going to give me a normal or whole number 17. Okay, we're going to use that as we move forward. This is what we talked about when we started square roots, this idea of prime factorization, right? Breaking a number down to its primes. 48 can be broken down into 8 and 6, 6 broken down to 3 and 2, which are primes. 8 can be broken down into 4 and 2, and 4 can be broken down into 2 and 2, and here's the collection of prime numbers that I, of course, could list right here. So if I wanted to, simplify the expression square root of 72, there's really 2 ways I can go about this. The first thing I'm going to note is that there's no square root for 72, right? 81 is 9 and 64 is 8, so it's somewhere in between 8 and 9. So based off of that, I'm going to have to simplify the root. I'm going to show you 2 methods, right? We talked about this in class. There's kind of a long road and there's kind of a short road. Let's start with the long road. That requires you to prime factorize. So you'd say something like, here I have the square root of 72, and I can break that down into its prime factors. So you can pick any factors. Let's just start with 8 and 9. I have the square root of 8, square root of 9. That breaks down into 4 and 2. This breaks down into 3 and 3, which these are primes, so I'm done here. And I can break down 4 into the square root of 2, square root of 2. And now do you see that I have all primes? It doesn't matter which factors you pick. You could have picked 36 and 2. There's plenty of options that you could have picked. Just for this example, I decided to go with 8 and 9 and broke down the prime factors. You get the same prime factors. So I'm going to list them all. I have root 2, root 2, root 2, root 3, root 3. You're going to look at this and go back to that concept we talked about before, that if I have pairs, right, they just become normal numbers. So a pair is going to become a normal number or a whole number. So I can look at this and say, do I have any pairs? Well, of course, I have a set of 2s. Just one set becomes a whole number 2. This root 2 has no other pair to be with, right? So I'm going to leave that as root 2. And then this has a square root of 3 pairs, so it becomes a normal 3 or a whole number 3. Now remember, this is multiplication that separates everything here, just as much here. So I can rewrite this as 2 times 3 times root 2 and write in the form that we like, 6 root 2. That's our answer. This is a long road. You break it down all the way to its primes, you list them, look for pairs, and order in the way we like, which is whole number, then our radical. The short road is a lot quicker. You just say square root of 72 and it'd say, what's the best perfect square that goes into 72? Well, that's where I'd pull up this chart right here and I'd say, well, 144 doesn't go in, 121 doesn't go in, 100 doesn't go in, 81 doesn't go in, 64 doesn't, 49 doesn't. Well, would you look at that? 36 goes into 72. So if I took this Now I broke this down into my two my two factors. I do square root of 36 and square root of 2, because 36 times 2 gives me 72. And you'd say, well, the square root of 36, that's a 6. This is a prime, so it's done, and you just get 6 root 2. Feel free to use any method. I would practice the number sense of taking the short road, because obviously you can see how much faster it is. It leads to less mistakes. But of course, if you need to prime factorize, write down everything with pairs, cut them out, and then multiply them. That for sure could work for the homework tonight. Remember, check the answer key at the bottom and email us if you have any questions.